What's up everyone? Peppery here. In today's video, we are diving into something pretty cool. How to deploy an app blocking policy using Intune's app control for business feature. Now, blocking apps on endpoint isn't exactly new territory. Third-party security solutions have been offering this kind of functionality for years. But here's the thing, Microsoft's native stack can absolutely do this too. And honestly, it's more powerful than most people realize. There are basically three main ways to pull this off natively. The first option is the registry route, where we leverage the classic image file execution options registry path. It's old school, but it still gets the job done. The second one is mlocker, the tried and true approach that's been around for years, and a lot of admins still rely on it today. And the third, the one we are really here for, is WDAC or Windows Defender Application Control. This is the modern, more robust option, and honestly, it's where Microsoft is putting all their focus going forward. Each of these has its own flavor and its own strengths, and today we are going to break it all down. So stick around, trust me, you're gonna want to see this one. WDAC stands for Windows Defender Application Control, and it's recently been rebranded to App Control for Business. When it comes to Microsoft native app control, mlocker and WDAC are the two most compared options. Both use a whitelist approach, but WDAC lets you set tighter, more security-focused policies. Since app control for business is the newer tech, with more update on the way and stronger security. That's what we are going with today. Head over to Intune Admin Center, then jump into Point Security. And right there, you will find the App Control for Business menu. Click the Create button and you can start building your policy. Now there are two ways to deliver it, built-in or XML. In real-world scenario, through XML file upload is the one you will be using most of the time. Microsoft provides a handy tool called the App Control for Business Wizard. Just search for it on Google and you can download it right away. Just a quick heads up, I've already got it installed and ready to go on my end. Once the installation is done, go ahead and fire up the wizard. Click Policy Creator to kick off the policy creation. In most cases, you will go with the multiple policy format. And when you are creating a policy for the first time, you will want to start with a base policy. Later on, if you need to add more allow rule, that's when the supplement policy comes into play. But heads up, supplemental policies don't support deny rules. At this step, you'll see three policy options: default window mode, allow Microsoft mode, and signed reputable mode. Each comes with a short one-liner explaining the difference. The simple way to think about it: the further left, the stricter; the further right, the more flexible. We are going to test each of these policies one by one. My take is that in most real-world setups, you will probably land on the second or third option, and then layer in your own allow and deny rules on top. So for the second and third policies, we'll spend a bit more time digging into how to handle exceptions. Alright, let's go ahead and build our first policy using default Windows mode. Give your policy a name, pick a location to save it, and click Next. Since we are planning to deploy this through Intune, go ahead and enable Managed Installer. For this demo, I'm turning audit mode off, but in a real production environment, I'd strongly recommend running it in audit mode first to monitor the impact before rolling it out. Keep clicking through, and at the end, you will get an XML file along with a file named using a GUID value. Alright, now let's jump back into Intune and set up the policy for deployment. Name your policy, upload the XML file, and assign it to your device group. To check whether the policy has been applied, just head to the path below and see if the same GUID file has been created there. You can also confirm the policy is in effect by heading over to Event Viewer and navigating to the path below. On top of that, you can also verify it using a PowerShell command. In this mode, anything that isn't natively provided by Microsoft gets blocked. To put that to the test, let's try running Chrome and WinRAR. And over in the event log, you can clearly see the set record showing which policy was responsible for the block. Now, let's unassign the device group from the current policy and try applying a different one. Now let's spin up another policy from the template and give it a try. Comparing the original policy with the second run is honestly pretty tough. So let's just deploy it and see if it behaves the same way. Chrome doesn't work here because it doesn't have a Microsoft sign signature. This time, let's modify the policy by adding the main program execution path to the allow list. We'll start by editing the existing policy. There are several allow methods supported, but for now, we'll keep it simple and add rules by wildcarding the main path. For reference, the official docs also show that you can specify paths in a variety of ways. Coming back to it, we'll wrap up creating the policy, then walk through editing and deploying it. First, let's check whether the policy has actually been applied. Now, let's test it by running Chrome and WinRAR. And as you can see, they are no longer getting blocked. Exactly what we wanted. After confirming the allow rules work, we also need to check that the other paths are still getting blocked. A good way to verify this is to run a file from the downloads folder. You will see the installers get blocked, which confirm the test. With this approach, you can effectively block users from installing extra apps beyond the ones your company has deployed or manages. Personally, I think the third policy is the most realistic way to set up a deny policy. I haven't fully tested every scenario, but it felt like officially installed program get allowed by default. Now, when we run the test, legitimate mainstream apps aren't getting blocked. As you can see on the desktop, the exe file I built myself gets blocked since it isn't verified. Now from here, let's edit the existing policy to allow other programs while adding a deny rule to block WinRL, then deploy it. The pattern is the same as before. Here we'll add WinRL to the deny rule. Now let's test how Chrome and WinRAR behave. Now, finally, we'll cover how to monitor it. If the device is onboarded, you can do that through advanced hunting. In this way, I believe you can flexibly implement app block policies. I'll wrap up this video here. If you found it helpful, please subscribe, turn on notifications, like, and leave a comment. Thank you.